Minute 19, and I'm back. I know. You're probably like, where have you been? I think I did minute 18 maybe a week or two ago. Please forgive me. I am trying to be consistent. I started another workbook study on fractions, so make sure you check that one out. As always, I put all the information for my courses and the workbooks and all of that great stuff below, so you can easily grab the material, grab the workbook, and join me, okay? So let's tackle minute 19. We're going to start with problem number 1. And we're going to go ahead and set this up. Rules for subtracting decimals. Always line up your decimals, which I am doing. You can view this as 8 tenths minus 5 tenths, or 80 cents minus 50 cents. But let's go ahead and subtract. I am going to start with 8 minus 5, which is 3. Bring down my decimal, and then just bring down my 0. Ooh, that is a crazy 0. So 0.8 minus 0.5 is 0.3. 8 tenths minus 5 tenths is 3 tenths. All right. Next problem. Circle the greatest number. So with decimals, I always tell my students, think in terms of money. We would read this as 55 cents. Read this as 50 cents. And I am going to round up here. I am going to look at the number in the thousandths place. And because it is a 5 or greater, what in the world? 5 or greater, 5 or more, you're going to round up. You're going to round up the 0 to a 1. So that becomes like 51 cents. So the greatest value for this one is going to be, or the greatest number is going to be 55 cents. How do I know? Because 55 cents, is it better to have 55 cents, 50 cents, or 51 cents? 55 cents, right? Okay, so let's look at the next one. Circle the number with the least value, the smallest value, and we're going to tackle it the same way. This is about 9 cents, and let me get my eraser because this problem is hiding a little bit of it. This is about 9 cents. Once again, I'm paying attention to the number, the 2 in the thousandths place, to determine what I'm going to do with my 9 in the hundredths place. So this is about 9 cents, because we're thinking in terms of money, right? This value would be about 3 cents. Once again, I'm looking at my 9 and my thousandths place to let me know whether or not I should round up or keep my 2 the same that's in my hundredths place. So I'm going to round up to 3 because 5 or more you're going to round up. All right. And then this one would be about 4 cents. Once again, I look at the 3, which is in the thousandths place, and it's 4 or less is 3. So I'm going to keep the 4 in my hundredths place the same. So the smallest value, the least value would be 3 cents. Okay, 3 cents. And I'm going to go ahead and scroll up. Well, I guess I have enough room to work number 4 here. A equals 9, then what is a squared, or a to the second power? So where I see a, I'm going to replace it with 9 because the problem says that a is equal to 9. So wherever I see an a, I can put the number 9. So 9 to the second power simply means 9 times 9, not 9 times 2, 9 times 9. And 9 times 9 is 81. All right, so let's erase and scroll up. Let's see how far can we fit them all in. Yes, we can. Here we go. Number 5, if 3 times x is equal to 27, then what is the value of x? Let's set it up. I'm going to go ahead and work this as a one-step equation because it is a one-step equation. Although for some students, if you are comfortable with your multiplication facts, you probably see, oh, 3 times 9 is 27. But let's follow through with the one-step process. We're going to start on the left-hand side because that's where our variable x is, and that's the variable we want to solve for. The opposite of multiplying by 3 would be dividing by 3. These cancel, leaving us with x on the left-hand side. 27 split into 3 groups, or 27 divided by 3 is 9. So x has a value of 9. So once again, you can check it by plugging in 9 where you see x. 3 times 9 is 27. So this answer is correct. Okay? All right, so let's look at the next one here. 3 feet is equal to how many inches? Okay, so I know that 1 foot is equal to 12 inches, right? So another foot would be another 12 inches. And then another foot would be another 12 inches. So this is 3 feet. 1, 2, 3. So what's 12 plus 12 plus 12? Or what's 12 times 3? Which means this would be 36 inches. Okay? I should have put the inches here. There we go. Done. All right, let's look at number 7. Once again, we're going to use our order of operations. Let me write it over here. Do we have any... Oh my gosh, why does it do that? Okay, let me exit out. There we go. And for some reason, it erases everything, or it erases everything to me. But sometimes when I play it back, everything is still there. So I don't know. So hopefully, why does it do that? Okay, I'm gonna try this one more time. Maybe I am writing and I'm not hitting everything. I don't know what triggers that. Let me write the PEMDAS right here. I'm gonna write it fast as if that's the reason why. Okay, do we have any parentheses in number 7? No, we do not. Do we have any exponents? No. We do have some multiplication and division. We have multiplication, so let's do that first. So this becomes 3 plus 18. And so the last thing we need to do is just add 3 plus 18. 18, 19, 20, 21. So 18 plus 3 is 21. Okay. Next problem says to place these in order. Order these numbers from least to greatest. And I'm going to use the strategy I showed earlier, just thinking in terms of money. Least to greatest. My smallest value is going to be 8 cents. So I'm going to put that here, 8 cents. And then my next, this is 80 cents. It's understood to have a 0 behind it. So this is 80 cents. And then my greatest value is going to be $8. Okay. So 8 cents, 80 cents, and then $8 is the order. Okay. Let's keep moving. Number 9, a field goal is worth 3 points. The Bears have kicked 4 field goals. How many points is this all together? All together is a addition word. We also know multiplication is a way to do addition quickly. So we know a field goal, 1 F is worth 3 points, right? So if they kicked 4 field goals, we could just do 4 times 3. And we know they have 12 points. But let's just set it up. Another field goal would be 3 points. And then another field goal would be 3 points. And then another field goal because they kicked 4 field goals. So you can see you're adding 3 together 4 times, or you can view that as 4 times 3. Okay? And our last problem. 3 times 2 times 4. So we can go back and look at our order of operation chart that is here. Once again, we have no parentheses, we have no exponents, and we only have multiplication this time. So let's do it in order from left to right. We're going to do 3 times 2 first, which is 6. Bring over the times 4. And then we will end with 6 times 4, which is 24. And we are done. All right, I will see you for the next minute. See you later.